So, greetings students. Next we'll be moving to your AC distributors in this lecture. So, this is your lecture 3. So, in the AC distributors, what you will be seeing is the same thing what you have considered for your DC distributor also. We'll be considering here your distributor load as well as your concentrator load. And then in the AC distributors, we will also see about your unity power factor, then different power factor like lagging, okay, and then leading power factor also we'll be seeing. Then in case of your unbalanced condition, how your AC distributors will be acting also we'll be seeing. So moving on, voltage drop in your AC distributors in case of your unity power factor. This will be more or less the operation will be similar to that of your what you can say your AC distributor fed at one end. It will be more or less the same, but here you will be getting your R plus JX term as your impedance. Okay, so here you can see the length is L1. Okay, so here it will be A to B, so it is fed at one end. Okay, then CD, so there is two loads connected, so it is a concentrated load L1 and then L2. Okay, so distance from your feeding point to your load 1 will be L1, then your load 1 to load 2 will be L2, and finally it will be L3. Okay, so R is your resistance. At the same time, X is your inductance, inductive reactance per unit length. Okay, so here the feeding voltage is Vs. Vs is your feeding voltage, and V are the sending end voltage, and Vr is your receiving end voltage. So the sending end voltage will be the summation of your the drop across your receiving end. So here you have to apply your KVL again. So if you are applying a KVL means it is the receiving end voltage VR, okay, VR plus the drop across from A to C plus your drop across from C to D and drop across from your D to B. So drop across your A to C is the current flowing through A to C, that is I1 plus I2 plus I3 plus the entire length L1, okay, L1 into the impedance, which is nothing but R plus JX. So this entire thing is similar to that of your inductive, that is your DC distributor, which is fed to your single end. Okay, finally you'll be getting the voltage drop as here. Sending end minus receiving end will be equal to I1 L1 R plus I2 L1 plus L2 into R plus I3 L1 plus L2 plus L3 into R. So here the voltage drop at far end or the receiving end of the distributor is a summation of the moments across of various current tapped off from the feeding point. Okay, so this is the same thing what we have considered for your DC distributor also. Next, coming to the next one, loads at the different power factor. Okay, so if the power factor cos pi value is positive or the negative the value, then that is it is a leading or if it is a of a lagging, then what happen is that we'll be seeing the industrial loads have lagging power factor since most of the load is inductive, and in the calculation of the voltage drop in the distributor feeding such as loads, the inductive reactance must be taken into account. That is, they are saying that you have to take your inductive reactance X. So the voltage drop can be calculated by replacing R by R plus Jx. So that's what we have done in the previous case also. And here the current will be I will be replaced by I into cos phi minus J sin phi. Okay. So here, based upon the type of load, you have to consider your this parameter, current parameter I into cos phi minus J sin phi. The voltage drop up to the far end will be given by, again you have to apply KVL over here. So here this is also a concentrated load because you are tapping out the loads from particular single point. So here the voltage drop will be the voltage rise, that is your feeding point will be Vs will be equal to I1 cos by 1, that is from your load 1 L1 and then L2 and then your L3. So after this, you have to multiply inside. So you'll be getting, if you are multiplying inside, you'll be taking a common out. The common term you can take it out as I1 L1. And here you can take it as I2 L1 plus L2. And here you can take it as I3 L1 plus L2 plus L3. So these are the common terms you can take. Okay, so this is how it looks like. Okay, for your different power factor. Next, coming to the distributed load. Now we'll be considering your distributed load. So distributed load seems with the range of your loads. So for the range of loads, what you'll be doing is you'll be taking into account your integration step. So you'll be integrating it. So here, let a current I is at power factor cos y tapped per unit length. So the current flow in the distributed load will be that of the same. Okay, A to B. So here the I value will be the same. So that's what here they're saying. Then the voltage drop will be sum of the moments up to U. So the same thing what we have considered in the previous case, up to U. You have to add up to U plus the moments of load beyond U. That is this one. That is the du beyond U assumed acting at the distance U. Okay, so you will be getting like this r cos phi iu du plus x into sin phi iu du. So this is also applicable for your different load power factor. So that only here again your cos phi plus sin phi term is coming out. Plus I L minus U. So up to this it is nothing but your sum of your moments up to U. So after this corresponds to a moment of loads beyond U. Okay. So next you will be integrating it with respect to your U. So here this thing will be du will become U, and then you will be applying to U minus 0. So 0 term will be cancelled out. So next same thing will be applicable to this cos phi also, and then sin phi. So finally you will be getting the voltage drop, that is Vs minus Vr will be equal to other or Va minus Vb. So here it is Va minus Vb will be equal to half I L square R cos phi plus half I L square x sin phi. So here both your resistive and your inductive terms will be present throughout your for AC distributor. Okay. So both concentrator and distributor load, it is possible that an AC distributor has both concentrator and distributor load. So here the mixture will be again coming out. So the combination of both loads will be coming out. So what we'll be doing is we'll be having both small I as well as capital I. So capital I corresponds to your this concentrated. Okay, concentrated load will be contributing to capital I, whereas small I will be contributing to the range of values, nothing but your distributed load. So uniformly distributed load at both the ends. So here, if in AC distributor along length L having uniform load at power factor cos phi, both the ends means, so here the minimum voltage will be occurring at your midpoint. So this is a very important one. The minimum voltage will be occurring at your midpoint. So the voltage drop will be at the midpoint will be, this is your formula. Okay. So in case of your unbalanced load, okay, unbalanced load, the AC distribution supplies a mixture of three phase, right? So unbalance is only possible in case of your three phase. Okay. If the degree of unbalance is lost, that is, if the unbalance effect is very high, like this, if it's going with the harmonics and other thing, the phase shift and the amplitude drop, okay, the voltage drop in the neutral wire has also to be taken into account. Okay, in case of unbalanced system, there will be a voltage drop across your neutral wire also. So that also has to be considered as a voltage drop. So this will be get in an additive manner. The voltage drop calculations are done for each of four wires. So normally we'll be using three phase four wire system. So What they're saying is you have to take into account your neutral also. Then the voltage between each phase and the conductor and the neutral conductor of the foreign can be calculated. Okay. So this is what with respect to your AC distributors. So here, how to maintain a equal maximum potential difference between any two conductor and the current is and the earth is given. Okay. So this is with respect to your DC and AC system is given. So up to here it is DC and AC. You can just go through it. Sometimes they might be asking problems through this. So the possible questions they might be asking are brief about your AC voltage distribution, types of your AC distributor, unity power factor load is a very important unity power factor load, and then unbalancing load is also sometimes they'll be asking. So this is what with respect to this lecture. Thank you.